A couple minutes late. I've been trying to figure out how this whole thing works, but I think we got it sorted out. Now, I want to say a couple comments before we get going in the Hangout here. The first thing is that if I go too quick, because I'm going to go through a lot of material, we're going to cover, I think, 8 different icons of evolution in this one talk, and so it's going to cover a lot of material. I want to let you guys know that there's actually a gift this I don't know if you can see that this month. If you donate to STR, they're actually giving away my talk, Shattering the Icons of Evolution, for your support. And this is a talk I gave at the Rethink event in Southern California. This was just this past September. And the video turned out really well. The guys who were editing did a fantastic job at kind of working the slides in to the into the video. So it turned out really well. So you want to get that for sure. So we're going to cover some of that material. Also, in this Hangout, I'm going to actually get my slides up. Now, this took a little bit of work to try and figure out. It wasn't easy. And so I think the presentation is so much better when you can see the visuals. And if you've been to any of my talks, if you've seen any of my presentations, you'll know that for a 45-minute presentation, I probably include 60 slides or something like that. I'm pretty heavy on the visuals. I'm a visual learner, and so I know a lot of, especially young people, they appreciate the number of visuals. So I'm going to have those up on the screen as well. Hopefully that works. So let's get into it. Now, before we get into the talk proper, when I go into youth groups and I talk to youth pastors and I talk to church leaders and Christian school teachers, I love to ask questions. And one of the questions I like to ask is this. What are you teaching your students about evolution? It's a strange question to ask a youth pastor, because I mean the usual response is, why are you asking me that question? I mean, that's not my job. We teach theology, we teach doctrine, and those are good answers. But they should be teaching evolution. And the reason for that is because the church in general at large has just ignored evolution for the most part. Even Christian school teachers I've talked to have ignored the subject. And so these kids, they go off to university. Some of them take biology. In a first-year bio class, they're going to encounter an evolutionist, right? And this could be the first time they encounter these arguments. And what do we think is going to happen when they encounter these arguments? Without a defense against it, these are going to have terrible consequences. And so I think we need to have a different approach. And that's why I developed this material. I actually taught biology in a public school classroom. I have a degree in physics, but I can teach pretty much any of the sciences. And so I actually taught evolution in the science classroom. But more on that in a second. So let's see if we can get my slides up here and go from there. All right, I think that worked. Excellent, excellent. All right, so hopefully you guys can all see that out there. Now, I've talked to well-meaning Christians who think that we need to isolate our students from ideas like evolution, lest a doubt should enter into their mind. In fact, I've actually spoken to high school biology. These are Christian school teachers who just ignore the subject altogether. They just skip the unit. I mean, we got enough to teach in the classroom. Something's going to get missed, and so they miss evolution. I think this is actually absolutely foolish. It may be right-hearted, but it's absolutely wrong-headed. There's a better way. I've actually, I said, I actually taught biology in the public school classroom, taught evolution. And when Christians find this out, it's so funny because the first question I get when I tell people I'm a Christian, I'm a creationist, you know, I believe in intelligent design, and I taught evolution. And it's like, how did you do that? How did you teach evolution? And my response is, I taught it well. I taught it well. I taught my students to evaluate the evidence for evolution. I believe a proper understanding of evolution will actually help our students to actually come to reject it, at least macroevolution. And so we need to stop isolating. This is why the slide's up on the screen. Stop isolating our students and start inoculating them, okay? And so what does the world think of this idea of evolution? I mean, Richard Dawkins is probably the most famous atheist, the most famous evolutionist in the world. He wrote a book called The Greatest Show on Earth, kind of giving evidence for evolution. And right in the opening pages, he says this: evolution is a fact beyond reasonable doubt, beyond serious doubt, beyond sane, informed, intelligent doubt, beyond doubt, evolution is a fact. And the evidence for evolution is at least as strong as the evidence for the Holocaust. In fact, in his book, he goes on to call those of us who deny macroevolution, we're deniers, like denying the Holocaust. Like there's Holocaust deniers, we're evolution deniers. He's not alone. I mean, there's many atheists and evolutionists who have come out and said the same thing. For example, Jerry Coyne, he says evolution is a fact. And far from casting doubt on Darwinism, the evidence gathered by scientists over the past century and a half support it completely. So he's arguing that we had some evidence back in Darwin's day, but over the past century and a half since Darwin, we just have more evidence that confirms it. And so I want to introduce Dawkins one more time because I love Dawkins. Just, you know, goes to the extreme sometimes when he says some of the things he says. And one of those things he wrote is an article in a book review in the New York Times. And he says, it is absolutely safe to say, if you meet someone who claims not to believe in evolution, that person is stupid. They're ignorant, stupid, or insane, or wicked, but I'd rather not consider that. And when I give this presentation out at conferences and churches, at this point I like to ask, who here does not believe in evolution, right? And if you say that you don't, I mean, okay, here are your options. You're either ignorant, insane, you know, stupid, or wicked. And of course, no one wants to be any of those things. And so actually, I didn't ask a fair question. As soon as I asked the question, who does not believe in evolution? If someone asks you, do you believe in evolution? Do you believe in evolution? Our response immediately should be, what do you mean by that? Now, many of you who are familiar with Stand to Reason obviously know that's the first Columbo question, right? What do you mean by that? And so we need to ask, as soon as the topic of evolution comes up, we need to start asking, what do you mean by evolution? Okay, because evolution, we're going to see in a second, has so many different definitions. And so that's got to be our question. And that comes from Tactics. Obviously, if you're familiar with Stand to Reason, you know the book Tactics by Greg Koukl, the president of Stand to Reason. You got to get this book, read it, and then reread it. And it's, I think, the book that I mean, I got tons of books behind me. It's the book I always go back to because this is the most practical book, I think, on my shelf. And so, so how do we answer that question? What do you mean? What do you mean by evolution? And so, yeah, I think I got a picture of Lieutenant Columbo up here. This is the Columbo tactic, right? So read the book. That's my endorsement of the book. Greg didn't ask me to endorse it, but just buy it. You know, just buy it. And so, what are the definitions of evolution? There's many. I'm going to give 6, I think. Some are uncontroversial. For example, it can be change over time. Like everyone agrees that living things change, okay? Everyone agrees with that. So that's one possible definition. It can mean change in gene frequency in a population. This happens every time 2 people get together and have a baby, okay? And if you're a youth listening, ask your parents about that. So you get some genes from mom and you get some genes from dad. And I always tell people I got the hair gene from my dad. And if you've seen me, you know what I'm talking about there. The third is the mechanism of natural selection and random mutation. So I'm going to speak more about the mechanism in a minute here. The fourth is limited common descent. Limited common descent, that's the idea that you have these this creation forest of life, okay? And so all dogs would go back to the gray wolf, okay? All dogs go back to the gray wolf. And so you don't have one kind of animal evolving into a different kind of animal. It's, I mean, this is taught in Genesis. And so these are uncontroversial. Everyone holds to them. I've never met anyone who didn't hold to this form of evolution. If you don't want to remember all 4 definitions, just think microevolution, okay? And this is not a creationist term. I have evolution textbooks that use the distinction micro and macroevolution. So I think they might be helpful for this discussion. Now, on the controversial side, and when I say controversial, of course, the majority of the scientific community, they're evolutionists in the macro sense, which we're going to see. So it's not controversial to them, but there's a growing number of scientists, and there's a growing number of people who reject these 2 that I'm going to mention here. And so one's universal common descent, and that is basically, think the tree of life. Every textbook has a tree of life. And so 3.8 billion years ago, you have this universal common ancestor, a single-celled organism that evolved from a prebiotic soup. And then from there, I mean, that's the story. And then from there, you basically get the entire diversity of life. And so on the tips here, we have Brett Kunkle related to the chimpanzee, who's also, I mean, we could find a common ancestor with the banana on the tree, okay? And so you can see that handsome dude there in that thinking position. Oh, and there's Brett too. Brett doesn't like that I put that in there, but that's okay because Brett's not my boss. And then there's number 6. All organisms are descended from a common ancestor, as we just said, but this is solely through an unguided natural process. Some textbooks say undirected or random natural process. This is a textbook definition, okay, of evolution. I don't think I've come across one evolutionary biology textbook that didn't have a definition similar to that, number 6. Now, I would call macroevolution, and this is where I am going to argue that I'm not an evolutionist in this sense. Okay, so in some senses, I'm an evolutionist in the first 4, but in the next 2, I'm not. I wouldn't hold to the theory. And so what we're going to do now is what I'd like to do is I'd like to look at the evidence used to support macroevolution. Okay, so you have the evidence for evolution, and I'm going to break it into 3 different categories, okay? These are categories that I've come up with. They may not be perfect, but I think you can kind of fit the textbook icons of evolution into one of these 3 categories. And so these are exaggerated extrapolation, egregious error, and equivocal evidence. Okay, so let's just look at each one by one. The exaggerated extrapolation, this is probably the most common mistake or misstep made by evolutionists. It's a mistaken projection, okay? Evolutionists take microevolution, all those examples, and we'll look at some, And they think that if they add enough time, they get macroevolution. Okay, so think of you know, we're going to talk about finch beaks in a second here, but so you got these finches and they have different size finch beaks, and they say, look at that minor change, look at that minor change. And then they extrapolate to the point where, well, if we can get minor change like the beak size changing, maybe you could get a dinosaur evolving into a bird. Okay, so now you've extrapolated to this macro sense. And most evolutionary biologists think that dinosaurs evolved into birds. In fact, dinosaurs aren't extinct. They're, you know, feeding on our bird feeders as we speak. And so if you've had Kentucky Fried Chicken, you've actually had, I mean, Kentucky Fried Dinosaur. And this is, I mean, in any natural history museum, this is this is a standard line. So that's the first. The second is egregious errors. Egregious errors. And this is this results in essentially mistaken information. It's not mistaken projection, mistaken information. They just don't get the facts right. Okay, and so these are things that are included in textbooks, but I don't think they should be. This is outdated data, data that's been overturned, things like that. And so, if the theory of evolution is based on is as established as the evolutionists claim, then they shouldn't be using false and outdated evidence. And the last one is equivocal evidence. And this is evidence that could be evidence for evolution. I'll grant that. It absolutely could be. But it could also be evidence for creation. And so that's why I called it equivocal. It could go either way. And so we'll look at a couple examples of that. Now, I said I talked about the mechanism just briefly. Maybe you've been out of the high school biology classroom for a little while. And so let me just give you a little review here. So let's say we have two dogs, and those things on their stomachs, those are alleles, those are genes essentially, one for short hair and long hair, and we'll say they have a combining effect. So we have two dogs here with medium length fur, and they're going to get married and have kids. And so that pink bow is important. So we got, so they start breeding, and you got a short-haired allele or gene from dad and short hair from mom. And so you're going to get a dog with short fur. You could get a short from dad and a long from mom, and you're going to have, you know, medium. And the same is true if you just reverse the process there. And then finally, you get this dude with the really messy hair. And that is long hair gene or long fur gene from both. And so at this point, we haven't seen natural selection. We've just produced the different varieties of animal you can get with these parents. If we take these animals, though, we drop them off in a harsh climate, like I'm actually in Ontario right now, Canada, not Ontario, California, and it looks like this. No, it doesn't really. But it's cold, and if we drop these dogs off, well, the ones with short fur, sad to say, but they're not going to make it. And so here's the universal symbol of death. Now, if this guy with long hair, he can find a mate that has long hair, got the pink bow, so they're good to go, and their offspring are all going to have long fur. And so here we've seen natural selection in action. Nature selected out the weak, and the strong survive. Survival of the fittest is what it's often called. And they reproduce and leave offspring for the next generation. And so this kind of thing we see all the time. And it's actually, there's evidence of this in the textbook. So let's just look at some of this extravagant or the exaggerated extrapolation. The first is peppered moss. Moss have been studied in some detail for about 200 years. Before the Industrial Revolution, in Europe, the vast majority of peppered moss had light-colored wing patterns, which effectively camouflage them. You can see on the screen, there's a moth there you can barely make out, and that's because of light-colored tree and the lichen on the tree. However, due to widespread pollution, the population changed. In fact, the light color was very easy to see on the soot-covered trees. and the lichen had died off. And so now the black ones were more camouflaged. And so we see the population, the proportion of dark moss increased. Of course, with all the pollution control, we've actually had the trees getting lighter again, and actually the lichen growing back. And so we can see the population actually rebounding, which is kind of neat. But notice, what have we seen here? I mean, this is an example of evolution in action, but really, I mean, it's survival of the fittest, but it doesn't explain the arrival of the fittest, doesn't explain the arrival of the moths in the first place, which is really what we're after. Where did the moth come from to begin with? Now, I should say this whole story has come under fire. It could be that much of this is made up, but just let's grant the whole story. Okay, if we just grant it, we're still not seeing much in the way of macroevolution. We're just seeing natural selection in action. What about finch beaks? Every single biology textbook I have ever seen has included Darwin's finches. Okay, when Darwin was on the Galapagos Islands, he studied these finches, something like 13 different species of finches. And the main difference in these was the beak size and shape. And they were very highly adapted for their particular environment and what they were eating. Some ate bigger nuts, would have to break in those, so had a larger beak, whereas some had smaller beaks for eating insects. Others had narrow beaks for getting into melons. And so you could see here, again, this is kind of an evolution in action in a sense, microevolution. During periods of drought, you could see they have actually measured an increase in beak size during droughts, because the bigger beaked birds can survive because they can get into the nut, crack into those nuts. But then when the drought goes away, the beaks actually, the size bounces right back. And so we got to ask ourselves, is this evidence, is this kind of evidence that turns over millions of years a dinosaur into something like a bird? And the answer is, I don't think so. I mean, we've seen, this is evidence for micro, not macroevolution. If you want to show that that macroevolution is true, you got to provide the evidence, and that certainly isn't one of them. Now, I should say, natural selection on its own doesn't do the trick. You need mutations. Mutations are key. In fact, there's a textbook, there's a website called Understanding Evolution. It's put on by the University of Berkeley, and I use this site when I taught evolution. So it's a great website for kind of getting an overview of what the evidence is and what evolution is. And it says this: mutations are essential to evolution. They are the raw material of genetic variation. Without mutation, evolution could not occur. Okay, and so we must have mutations. That's providing the variation to get, in this case, these two different dogs, the Great Dane and the Chihuahua. Now, here is another evidence that's in almost every textbook. It's antibiotic-resistant bacteria. And this will be our third icon we'll look at. For this particular one, antibiotic-resistant bacteria is claimed to be evolution before our very eyes. Okay, let me give you an example of what's called H. pylori, or Helicobacter pylori. This causes stomach ulcers. And so if you're a little squeamish, there's a stomach ulcer on this screen. And so you got this bacteria in your stomach, and he actually kind of eats away at the mucus lining and of your inner stomach, and it's not a good thing. But if you take antibiotic, well, the antibiotic will mix with an enzyme in the bacteria, and the two combine to produce a poison that essentially kills the bacteria. Now, here's the problem. Imagine there's an H. pylori mutation that doesn't actually produce the enzyme, okay? So the organism can survive without the enzyme. And so when you give the antibiotic is not the poison in itself. And so it doesn't kill the bacteria. No enzyme means no poison, which means no death. But notice what happened here. We actually the mutation broke something. It broke the enzyme, which is a complex structure, okay, in fact, that requires information to be even put together to begin with. And so the mutation broke it. It's a beneficial mutation that helps this organism survive. But think of the big picture here. Does this kind of thing lead to macroevolution? I mean, we're talking about breaking complex structures down. No, it's in the exact opposite direction of what we should see if macroevolution is true. And so peppered moths, finch beaks, antibiotic-resistant bacteria, even if you add all the time in the world, okay, it still doesn't add up to macroevolution, okay? And this is what is normally touted as evidence. Just give it enough time. Time is like abracadabra. It's like the magic words. But this is not the case. This is not evidence for macroevolution. Okay, let's do egregious errors. Egregious errors are kind of get me a little bit hot and bothered. They get me a little upset because some of these, especially the last one we'll look at, I mean, it shouldn't be in the textbook. One is transitional forms. Often transitional forms are given as evidence for macroevolution. Look at how, you know, the whale has changed. We have these different transitional forms, or they look at tetrapod evolution. I'll show that one in a minute here. And so essentially, we're told that creatures evolve very slowly over millions of years. For instance, evolutionists will assert that, we said this, dinosaurs evolved into birds. Now, this is a remarkable claim that requires some, I think, evidence to back it up. And so if it's true, we should find an enormous amount of transitional forms going from dinosaur into bird. And so you'd have, like, you know, 100% dinosaur, and then 90% dinosaur and 10% bird, and, you know, 80% like slowly on its way, and then 20% bird, and then 70-30, you know, 50-50, and then start to work our way the other way. And that's what we should expect if slow, gradual evolution over millions of years from dinosaur to bird is true. And so there are, I mean, we found a handful of highly disputed transitional forms. Archaeopteryx is one of them. Now, let me just say, Archaeopteryx, I think the evidence is strong that it is just a bird. It's a perching bird. It's a weird bird. It's got teeth. It has this kind of bony tail with feathers off the back. But I mean, even evolutionary biologists themselves, many assert that Archaeopteryx is a bird. And so there's a handful. Now, what we should find, though, is like just in the millions and billions of transitional forms. If we're talking millions of years and the number of organisms that truly exist, and that's just not what we find. They're missing. In fact, they're often called missing links because they are missing links. I mean, it's not too hard to get. And so this was a problem back in Darwin's day. If we're honest, the Origin of Species says this. It says the number of intermediate varieties, those transitional forms, which have formerly existed on the earth must be truly enormous. I'm with Charlie on this one. It must be enormous. Then why then is not every geological formation, rock layers, and every stratum full of such transition or intermediate links? Geology assuredly does not reveal such a finely graduated organic chain, and this perhaps is the most obvious and gravest objection which can be urged against my theory. So Darwin was honest here. He looked at the fossil record, and they just didn't find it, but he thought they would. Now, Stephen Jay Gould, who was a Harvard paleontologist, passed away now, but he actually admitted to this. He said, even, you know, 150 years after Darwin, the extreme rarity of the transitional forms in the fossil record persists as the trade secret of paleontology. You know, don't tell the high school students this, but this is the trade secret of paleontology. The evolutionary trees that adorn our textbooks have data only at the tips and nodes of their branches. The rest is inference, however reasonable, not the evidence of fossils, okay? So this is the guy who deals with the fossils themselves, and he's saying it's not there. Now, some evolutionists will say, oh, you're quote mining. You're just pulling this quote out of thin air because it fits your creationist ideas. No, no, not at all. In fact, Stephen Jay Gould, because he looked at the evidence, he came up with his own idea of evolution, not slow and gradual. Okay, slow and gradualism. This is Dawkins. He argued for slow and gradual evolution. What Stephen Jay Gould came out with was what was called punctuated equilibrium. Basically, we don't see the fossils, and so evolution kind of works in these really quick jumps. And so you're not going to find the transitional forms because punctuated equilibrium is true. Of course, Dawkins argues against punctuated equilibrium. Stephen Jay Gould argues against gradualism. I think they're both right. I think they're both wrong, right? And so, if that makes sense. And so, here's another example. You have tetrapod evolution. So going from something like a fish that crawls out of the ocean. They say this happened, around 400 million years ago. And so you go from something like Euthenopteron and Pangdipteres and to Ichthyostega and Acanthosaga. Man, if we could find a transition right in the middle, like at 375 million years ago, that would just prove evolution, wouldn't it? And sure enough, they found this creature in Canada, actually in Nunavut, called Tiktaalik. And just for the record, they find the bones and not even a complete set. They don't have the color of the skin and the speckledness and all this other stuff. Obviously, this is artistic impression here. And so you have this creature that seems to be almost like a intermediate between starting to walk, but not really walk, maybe on the ocean bottom, called Tiktaalik. Here's the issue, though, and this is why this argument has been moved kind of to a footnote in most textbooks. It's because they actually found tracks of a tetrapod creature about 395 million years ago. Why is this significant? This was in Poland. It's significant because the transition is too early. Your Tiktaalik has to come before these tracks. I mean, these tracks indicate there's an animal. I think the feet were something like 8 feet apart. This is a huge creature, and so Tiktaalik can't be a transitional form. It shows up too late. It needs to be 400 million years ago or 410 million years ago or something like that. And so that's why Tiktaalik isn't talked about that often anymore. But here's the one I have a real issue with. It's embryology. Now, Darwin thought that the argument from embryology was one of the strongest of all of the arguments for evolution. In fact, in a letter to his botanist friend, Asa Gray, he wrote this: "It's curious how each one, I suppose, weighs arguments in a different balance." So he's saying there's different, people think different arguments are better or worse. He says, embryology is, to me, by far the strongest single class of facts in favor of change of form, okay? And so this was a strong argument for Darwin, and it's still in the textbooks today. In fact, this is an image from, I think, a 2015 textbook. And you can see here, we have the embryos of a fish, a salamander, a tortoise, a chicken, and a human. They all look so familiar, or they all look so similar. And as they develop, they get a little bit more different. And so this argument actually goes back to a German biologist named Ernst Haeckel. And he drew these embryos, essentially what you're looking at in the textbook. And he said that this early similarity shows that they came from a common ancestor. In fact, look, you got the gill slits. That's from our fish stage. Let me tell you, they're not gills and they're not slits. Okay, they have nothing to do with respiration. Those are folds because the embryo is curved over in a C shape. It's not a tail. In fact, the feet haven't started growing. The feet actually grow past that point eventually. But here's the real issue I have with this argument. Here's what the embryos actually look like, okay? Here's the, if you can't tell the difference, there's the drawings that are in every textbook next to the photographs of what they actually look like. Ernst Haeckel faked his drawings. They are a fraud. They are an absolute fraud. And this isn't creationist talking. This is recognized in the leading scientific journal, Science, okay? In fact, it says, and I screenshotted it here for you, it looks like it's turning out to be one of the most famous fakes in biology. This was in '97, and yet this is still in the textbooks, okay? And so something, this argument should not continue to be used in light of what we've discovered, that this is indeed a hoax, a fake. And so the last one I would like to look at is junk DNA. Now, for a long time, junk DNA has been argued as evidence for evolution. There's this accumulated non-functional DNA that just has to be accumulated over millions of years of evolution. At least that was the argument. That was the argument. Let me show a quick video here of just describing DNA.
I got some junk in my trunk, or in my DNA, or both. Hey guys, it's Trace again for D News. Our DNA might be mostly nothing. Yep, nada, zip, just trash. Scientists learned in the 80s that of all DNA, maybe 2% contains actual genes. Genes are the switches that turn on the production of proteins that make us who, how, and what we are. The rest of that 98%, we're not sure what that does. If anything, it might just be junk DNA, or what the scientists call non-coding DNA. Since its discovery, scientists have found that this disorganized and mostly mysterious section of our genetic code doesn't really seem to do anything. So why don't we just cut it out? Because we're not entirely sure that it's useless. That's why it just seems to be. The scientists see it as just junk, waste. Humans are more like the lily. We've got something like 500 billion base pairs, with 98% of that being non-coding DNA or junk DNA. Why do we have it? No idea. Not even close. What do you think of this study? Do you think our DNA is full of junk, of years of trial and error of evolution, or are we missing the bigger picture?
So I think he's missing the bigger picture. I hope the audio came through with that video. Here's just a 10-second explanation. So he said there's a protein coding part of DNA. Our DNA is about, it's about over 3 billion base pairs long. And so 2% they think is protein coding DNA. The other part is what they would call junk. They said, hey, it doesn't code for proteins, it must be junk. Well, it turns out in 2012, this huge project, so they did the Human Genome Project where they mapped the whole human genome. And then the next project was the ENCODE project. And in this project, it was numerous scientists from multiple universities working, and a number of papers were published. They actually came out and said that they assigned biochemical functions for 80% of the genome, okay? In particular, outside the well-studied protein coding regions. And so this is very interesting because they're basically saying this part that they call junk, well, actually 80% is functional. It's doing something. It's not coding for proteins, but it's like switches turning things on and off, saying when things should be expressed and when they shouldn't, that kind of thing. Regulatory function. And so this, I mean, this lines up perfectly with a designer, and not with their idea that junk DNA is just accumulated over our evolutionary history. And let's move on from that one. So that shouldn't be in the textbooks either, but it is, unfortunately. The last section I want to look at is this equivocal evidence, because I think these are actually decent arguments for evolution, but they can equally be explained from a creation or intelligent design perspective. Let me explain. And so let's go with vestigial organs first. There used to be a list, over 100 over 100 different vestigial organs were on it. I know that's been whittled down because they found function for some of these things, like the appendix. You say it's functionless, but it turns out it might have some function to do with our immune system. There's the coccyx, there's the pelvis of the whale. But I want to go right to Dawkins' book because he says this: vestigial eyes are evidence for evolution. Given that cave salamanders live in perpetual darkness, so has no use for eyes, why would a divine creator nevertheless furnish it with dummy eyes? Clearly related to eyes, but non-functional. I mean, it's a good question. He's asking, we find these creatures often with the pigment is gone. They live in complete darkness. They have their eyes no longer work. And so, man, this looks like, why would a creator put an eye in something that doesn't really do anything? But there's some assumptions in play there. What do we say to Dawkins? Well, vestigial structures are entirely consistent with an intelligent designer, okay? They could be structures that were initially designed, but then lost their function through mutation and natural selection. Everyone agrees that the structure started out functional, but became non-functional, okay? So this isn't evolution. This is more like de-evolution, okay? What the evolutionist needs to do is explain the organ, how it got there to begin with. How did the eye get there to begin with, okay? Maybe some of you drive really beat up cars, you know, where structures like the air conditioning or the heater or the power windows or the lights or whatever, they don't work anymore. But just because they've become non-functional doesn't mean that they weren't designed to begin with. I hope that's clear, right? Just because it became non-functional doesn't mean it wasn't designed to begin with. In the same way, we see these vestigial structures like this eye that Dawkins brings up in his book. No, well, couldn't it be that it was designed to begin with and lost its function? I think that's a better explanation. Dawkins needs to explain where the eye came from to begin with. Okay, here is probably the best evidence offered for evolution, in my opinion. At least it's in the textbooks. I think homology provides one of the strongest evidences put forward. Here's why. Homology has to do with similarity between organisms. So evolutionists understand this similarity to be evidence for common descent, a common ancestor. Okay, so look at the human arm, the cat leg, the whale flipper, the bat wing, and say, look at the bone structures, okay? There's that similar pattern. They each start with one big bone connected to two smaller bones, and then they're connected to even smaller bones. And finally, there's this 5-digit pentadactyl pattern, or we just call them fingers, right? And so is this evidence for a common ancestor, common descent? Well, it certainly could be. It certainly could be. But what best explains the similarity? And so I want to use an illustration that I use with people I speak to. I'll often say, on the screen, you have a series of iPods, okay, and actually one iPad. And there is much similarity between them, much similarity. So how do we explain the similarity? Well, we could say it's common ancestry, you know, common descent. Maybe one evolved into the next over a long period of time. Some evolved bigger screens, like the iPod Touch, and some lost their screens. It became vestigial, like the Shuffle. Some evolved from black and white screens to color screens, and then all the way to touch screens. And then maybe some, through punctuated equilibrium, went from an iPod to an iPad. So you can explain that kind of through common descent and draw your lines and connect the dots, right? Of course, we know that that's not true. This is all common design. The reason these different iPods and the iPad are so similar is because they share a common designer, and that is Apple. And so in the same way, when we look at similarity between the whale flipper and the bat wing, sure, we could conclude that they are from a common ancestor, common descent, but I think we're also open to the possibility that it could be common design. It could be common design, a designer using similar structures, similar platform. In fact, I think it's actually a better explanation. It's not just a coin flip, and here's why I think it's a better explanation. So take the eye, for example, the mammalian eye. So you have the whale, the human, the mouse. Evolutionists would argue they share a common ancestor, common descent. So a common ancestor had such an eye, and then you get all these creatures that evolve with that eye. But then there's eyes like the octopus eye that they don't assert share a common ancestor with a creature with such an eye. In fact, they believe that the octopus eye evolved, listen, completely independent of the mammalian eye, okay? And so they call this convergent evolution. In fact, not only did the eye, this incredible complex structure that, I mean, we're developing cameras that almost pale in comparison to the optics of an eye. And so what's the best explanation? I would argue that the eye didn't evolve independently numerous times. I think the best explanation is that we have a common designer who uses the eye in multiple creatures. And so this seems to, at least to me, to be a more rational explanation for this. Now, I want to conclude with one last thing. Why is evolution so widely believed? I've offered some arguments against the traditional, textbook evidences. Why is evolution so widely accepted or believed? And partly the reason is because it's true, right? Evolution, on some definitions, is true. The facts back it up. And so we got to be clear on what we mean by evolution. Obviously, finches and moths and bacteria, they change. And so in this case, evolution's true. But why is macroevolution so widely believed? I don't believe it's primarily for scientific reasons. I think it's widely accepted for philosophical reasons. It's believed because there's a commitment to methodological naturalism. Methodological naturalism is simply means that scientists assume that only natural causes exist when they do science, okay? And of course, this is an assumption that just excludes the supernatural from the beginning. So you're not ever going to come to a supernatural explanation like design. And so all you're left with is macroevolution. Anyone holding to methodological naturalism is going to argue that creationism and intelligent design, well, those aren't even on the table. They're not possible explanations of the biological world, okay? But if we don't start with that bias, if we don't start with that presupposition, then we're open to, I think, more possibilities. And I don't think and I think we're left with the true possibility of an intelligent creator. So listen, even if all the evidence pointed away from evolution and towards an intelligent designer, if methodological naturalism is strictly held to, then you'd have to cling to the theory of evolution, okay, as the only possible explanation. It would be your only game in town. And so everyone needs a creation story, and that would be theirs. However, when considering the origin of the diversity of life, the theist is open to follow the evidence where it leads. And if the evidence points away from macroevolution, which I think it does, and towards supernatural intelligence, which I haven't actually argued for, I think there's good arguments for that, then I would say so be it. So be it. So I'm going to turn this, share my screen again if I can figure out how to do that. All right, now I don't know if there's a way I can take questions here. Can I take questions? What if I, oh, it's disabled. Give me a second here. I might not be able to take questions. I hope you guys enjoyed that. Again, like I said, I covered a lot of material there. If you have students who are in high school, or maybe you're a high school student watching this, you want to get this DVD. And with, I think, any donation to Stand to Reason, they will send it to you. They'll ship it to you. And it's called Shattering the Icons of Evolution. And it walks through, and you can obviously stop and start, and it'd probably be great to show to your youth group. But I don't think I can actually enable the questions, which stinks. So I'm going to leave it there. If you have any questions for me, feel free to message me on Twitter. Oh, wait, I'm getting a message from Brooke on how to show. Okay. Q&A. I got it. I hit the blue thing. I hit it. And then it says this feature is disabled. So Brooke, you must be watching this. Yeah. Yeah. What if I hit chat? Are people able to type in the chat? If you have a question, you could potentially enter a chat message, I think, or maybe that's only something I can do. If you're out there watching this, can you see if you can type a chat to me? Sorry, guys. I wish that I could enable this. I'm clicking the button and it's telling me this feature is disabled. There's no chat box. Ah, too bad. Because if I chat, share, showcase, camera, yeah, I don't really have many options here. Settings, no. So like I said, if you want to contact me, my email, I'll give you my email. It's tim@str.org. Tim, T-I-M, @str.org. You can feel free to email me. And I can follow up with you that way, or you can message me through social media. Twitter has my, you can message me through Twitter, which would be @TimothyBarnett. That's what my mom calls me when she's angry at me, Timothy. So Timothy Barnett is a great way through Twitter, and I can try to answer you in 140 characters or less. So thank you for joining. I had a great time. Next time we do this, I'm gonna figure out how to turn on the questions. And I would love to be able to have like picture in picture. So if anyone's watching this and they know how I can be on the screen, with my slideshow, like that would be awesome. So we'll keep working on this stuff. Thanks again, guys. Have an excellent evening. Bye.